familiar with, but I want you to know about it. You might hear somebody say the base and the argument. It means the same thing, that it can be used interchangeably. I won't use it, but I want to expose that to you in case you come across it in a textbook or in some other place. Okay? So, we know we're going to write a logarithmic function, have be positive real numbers, and y is equal to log of base b of x if and only if the inverse is true. Okay? Because they're inverses of each other. So these are only true if they're inverses of each other. Okay, you ready? We good to try some?
Yeah.
Okay. Okay, so we are going to learn to go from exponential form to logarithmic form. And remember, you are going to use, remember your base, your value, and your exponent. BE, base value exponent. So how am I going to write 2 to the third equals 8? 2 is what?
B.
The base. What is 3?
The exponent.
That's your exponent. So how am I writing 2 to the third equals 8?
Wait,
Three to the-
like, we can't write that fast.
Just write 1. You don't have to write them all. Let's start with 1. How am I going to write that in logarithmic form? Log, I'm starting with log. Log
2.
2, sub 2. I'm going to write that as sub 2.
3, type
It's BE, base value exponent. Base value exponent. Base value, and then it's going to be the exponent. So it's going to be log 2, right? There's my base.
log 2, 8 equals 3.
Okay?
Wait, but I get the x and y from the because you would think 3, isn't 3 the exponent over there?
3 is the exponent. Isn't that what we're trying to solve for? A log, repeat after me. What is the answer to a logarithm? An exponent.
Oh, so when we had it before, it's kind of like that is x instead of, okay.
Okay? So what is the answer to a logarithm? An exponent. One more time. The answer to a logarithm is an
Exponent.
exponent. Do you understand why I'm asking you to repeat this like 5 times now? You gotta you have to kind of wrap your head around it. And I don't know how else to teach that other than to tell you, repeat after me one more time. The answer to a logarithm is an exponent. Okay, let's try the next one. How are you going to write 10 squared equals 100?
Log 10 times 100 equals 2.
Okay, log to base 10, sorry, equals 2. Is everybody good with that? Okay, one more. Practice one. Okay. How about 4 to the negative 2 is equal to 1/16?
Log 4.
Log 4 to the negative 1/16.
No, log 1/16 equals
Eli,
-2.
Wendy Gilbert wants to see the second.
That's a lot of numbers.
So log 4. So can my exponent be negative?
Yes.
Yes.
Okay. What were the 2 things that had to be positive?
Base of that.
My base and my value. Because what is an exponent, a negative exponent?
That's small.
It's just a small number. Okay? So I can have a negative exponent, but my base and my values are going to be positive. All right. All right. So let's look at this. Let's evaluate log 10, log base 10, 10,000. Evaluate this.
Where's the equals?
There is no equal. You're going to, okay, what we're going to do is we're going to set it up, let y equal. Okay, you good with that? So what is 10,000? My base, my value, or my exponent?
Value.
It's my value. How do you think I might go about figuring out what the exponent is?
Solve for. No idea.
10 to the x, okay. Now, could I rewrite this and say, well, I'm letting y is my exponent, right? So 10 to the y is equal to 10,000. Is that correct? We rewrote it in exponential form. What could I do to that 10,000? What happens if the bases are the same?
You can, you got a trash compactor, whatever. You gotta
If
divide
I
by 10.
have the same base, can I rename 10,000 as 10 to the 4th?
That's a lot of work.
Wait, how did you get 10 to the y equals 10,000?
I was in logarithmic form. Can I go back into exponential form?
Oh, so you rewrite as exponential.
I rewrote. Yes, I'm thinking here. I can remember. I'm going to try and go back and forth. I need to be fluid because that's what I'm trying to solve for. And in this particular case, this one was pretty easy because it was like, oh, I can rewrite this as 10,000, and I know that's 10 to the 4th. So if the bases are the same, y must equal 4.
Can you move it over so we can see what you wrote on the side?
Oh.
Oh, okay.
Rewrite in exponential form, powers are the same, base, blah, blah, blah. Okay?
Wait.
I'm not talking about math right now. Sorry.
Restart.
Okay. Let's try the next one. Okay, evaluate log 0.5 32. And there was a mark there, and I apologize, I scribbled it out. Okay? So again, what the answer to a logarithm is a what? An exponent. Okay, so can I set this equal to y? Okay, and I'm going to write it in exponential form. So, can I change what 0.5 looks like? 0.5 equals what? 1/2. So could I say 1/2 to the y is equal to 32?
How do you change the bases?
Oops, sorry. I just rewrote it like that. Isn't 0.5 equal to 1/2? That's all I did. So I have 1/2 to the y is equal to 32. This was part of the first lesson that we did in exponentials, is can I rewrite 32 in terms of 2? Remember that lesson? I wanted to do it in 8, that first lesson that I thought I had made an error on, and it was like, oh, they did it in 2. So, and they happen to be 32. What is 32 in terms of base 2? 2 to the 5th? Okay, so if I have y is equal, can I rewrite 1/2 as bring my exponent up, and then I know that I have 2 to the negative y is equal to 2 to the 5th. Okay, this is all about knowing your exponents.
So you negative y equals 5.
So negative y equals 5,
So y equals negative.
so y is going to equal a negative 5. Okay, can my exponents be negative? Yes. I have a negative exponent. Is a negative exponent just telling me that I have what? A small number. Okay.
So,
What?
That's a new question. To
What's
get rid of log, is that just raising it to the y?
To get rid of the logarithm, remember I said that the logarithm, when we write in logarithmic form, it's the inverse of the exponential. So if I have the inverse, I'm going back to the exponential.
So that means that when you have log 0.5, it's just 0.5 raised to the y?
Yes,
Okay.
That's
that
it.
is, yeah.
that's it. Okay. All right. So you have a question here? This was just,
Oh, yeah,
okay. Rewrite in exponential form, power is the same base, rewrite. Okay, so, what is this? What is the answer to this? This is just using the form. The answer to this is what? What is the answer to a logarithm?
An exponent.
An exponent. That was a little cha-cha for you there. Okay, so what is the answer to a logarithm? An exponent, okay. I'm gonna give these to you like a million times. So the answer to an exponent, to a logarithm is an exponent. So, what is this? Is this really just asking the same question? Because this is the base, and what is this?
Exponent.
It's an exponent. Okay, this happens to be written in what form? This is an exponential form, and this one is in logarithmic form. And I know that when I have a logarithm, my answer is an exponent. Okay, so do these two things mean the same thing?
Yes.
Yes, they do. Okay? They mean the same thing, just written a little bit